Hey guys, welcome to the shop job demo for MC1. So this is our first actual motor control circuit that we're going to experiment with. So you're going to use a stencil to make this drawing. I hope you guys were able to get the stencil at this point. If not, it is online in a PDF format. You're going to include both the power circuit and the control circuit for this one. So we're going to do a lot of that moving forward. The power circuit is the three-phase power that we're controlling with the control circuit below. For this one, you're going to use a two-position maintained contact switch or a selector switch. You're going to wire a contactor, a lighting contactor, to control a three-phase Y-connected lamp bank using what's known as two-wire control. So in the previous videos, hopefully you guys had some time to watch them. It talks about three-wire control and ladder logic. So here on top from the disconnect through the lighting contactor to the lamps is our power circuit. And then we're going to be using the step-down transformer already in your booth to isolate the control circuit. So you need to bring line 1 and 2, or 2 and 3, or any combination of line 1 and 2, 208 volts to the line side of the control transformer in your booth. Out of the secondary side of that, which some of you guys have already used for the Highlight Delta shop job, you'll have an X1 and an X2 terminal strip already wired up. You'll notice that out of the X1 side, you have a small 3 amp circuit breaker, a little white circuit breaker in your booth. So that's going to be used to form X1. And X2 is the grounded side or the neutral side. All right, here in the control circuit, what we're seeing is this is the two-position selector switch. So again, use your multimeter on continuity. The selector switches are in the gray housing right in front of you, along with some of the push buttons and indicator lights that are in the same gray housings. So go ahead and find that two-position selector switch and understand how it works with your multimeter. Put it on continuity. Turn it on and off so that you're sure exactly which two wires you're going to use. It's very similar to a single pole switch. This is a maintained contact switch, so when you put it in the on position, you should have continuity. When you put it in the off position, it should act as an open circuit, and you should not have continuity. In the control circuit, you're going to go to the coil that's located on the contactor. All right, so let's jump over and take a look at that. So this is the contactor, or a very similar one to the one that you have in your booth. Okay, it is an electromechanical device. What that means is when we use electricity to energize the coil, it will perform a mechanical motion and close the three-phase power contacts up above. And this one has one extra contact, probably for a neutral. So you're going to land your power out of your disconnect on this terminal, which is pre-wired to a terminal strip. So on the line side of your contactor, okay? And these contacts go from top to bottom. So this would be line coming in, load coming out. Line coming in, load coming out. Line coming in, load coming out. So each one of these is a separate phase. Okay, so wire in the line side, come out of the load side, and go to your lamp bank. Keep in mind, this is a three-phase Y-connected lamp bank, so they should share a neutral on their way back to the disconnect. Furthermore, energizing the contact with the contactor's coil with 120 volts supplied by the X1 and X2 rails out of your control transformer will allow the contactor to close and turn the lights on and off. If you're having trouble, or if you're trying to figure out how this thing works, prior to connecting it, if you take your finger and push up on this coil, you could actually actuate those contacts manually. Again, by using your multimeter and manually pushing up and down on this coil with power off, you will notice that when you push on the coil, simulating the coil being energized, the contacts will close up top, and that is how the power will get to your lamp bank. Okay, so let's jump back to the control circuit real quick. That coil that I'm talking about you guys energizing in order to close the power contacts is down in this portion of the control circuit. Okay, so when you're wiring this up, you go out of the secondary of your control transformer that's already pre-wired for you to one side of your selector switch, just like a single pole switch in residential shop. Out of the other side, or the load side of that switch, you go to the lighting contactor's coil. Out of the coil, you go back to neutral, or the X2. So this is very similar to turning a lamp on and off in residential shop, but with using a single pole switch. The only difference is the symbol and the way the switch operates. All right, so down here we should see 120 volts between X1 and X2. Up top on the actual power contacts is where you're going to switch the three-phase power to the lamps in your booth. Notice how this isn't even using a neutral. So again, it's a Y-connected lamp bank. So long as you give current a path back to the source through one of the other lamps, they should all come on appropriately. Just take a jump back to the shop job. Okay, so in the shop job again, we're using a 2-position maintain contact switch. You're going to wire up to the 3-phase Y-connected lamp bank through the lighting contactor. And this is our first step towards more advanced motor control circuits, where we're going to build on this and make more complex circuits using control relays and magnetic motor starters. Good luck with this shop job. Please email me if you have any questions.